Many of us have read or heard about the building blocks of all matter we see around us, the atoms. We know how they look, their extremely small size, and that they consist of a central nucleus surrounded by electrons. However, most of us don't realize that atoms are mostly empty space. These tiny structures have large gaps between their electrons and nuclei. Imagine the nucleus of an atom is the size of a tennis ball. Moreover, imagine the atom as if placed in the middle of a soccer stadium. If you place this tennis ball in the center of a soccer field, the electrons would be orbiting at a distance near where the spectators sit in the stands. Imagine you can hitch a ride on the electron. From this vantage point, you'll see how far the nucleus is from the electron. Moreover, the electrons are smaller than the nucleus, about 10 times smaller. This means atoms are tiny, with a radius of around 1 × 10 to the -8 centimeters. These numbers are incredibly tiny and far beyond what we can see with our human eyes, but they are real and exist. Even though we can't see them, we know they are there because of their effects on the world around us. Richard Feynman once said that if, in some cataclysm, all of scientific knowledge were to be destroyed and only one sentence passed on to the next generations of creatures, what statement would contain the most information in the fewest words? I believe it is the atomic hypothesis, or the atomic fact, or whatever you wish to call it. All things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling when squeezed into one another. In that one sentence, you will see that there is an enormous amount of information about the world if just a little imagination and thinking is applied. Imagine being underwater. When you look at the water, it appears smooth and continuous. But if you could zoom in close, like 1 billion times closer, you'd start to see the individual molecules that make up the water. These molecules are called H2O, and they consist of 2 hydrogen atoms, represented by the letter H, bonded to 1 oxygen atom, represented by the letter O. In a simplified model, we represent H2O as 3 spheres, a larger one for the oxygen atom and 2 smaller ones for the hydrogen atoms. These molecules are always in motion, jiggling, bouncing, and twisting around each other. Despite all this movement, they tend to stay together, almost as if they are glued to each other. However, even though they remain together closely, the molecules do not stick to each other, so they can form a liquid called water. This is how water would be if we could distinguish the H2O molecules. Why do they remain close? And why don't they stick to each other? Let's see. If we could look at molecules with even more precision, we would see groups of atoms. What looks like the green ears of Mickey Mouse on the water molecule represents the hydrogen atoms. And what looks like the blue face of the Mickey Mouse is the oxygen atom. Each atom has a nucleus comprising protons and neutrons tightly bound together. except hydrogen, which is the only element in the periodic table that has only one proton. Surrounding the nucleus are electrons, which spin around it in different orbits. We know that the nucleus is positively charged, and the electrons are negatively charged. Opposites attract each other. Likes are repelling. Isn't it how life is? It is important to note that a more accurate picture of the water molecule's structure shows the hydrogen's electron in one of the oxygen's orbits. The outer red dots are hydrogen nuclei. They spin around the nucleus because their electron is trapped in the outer orbit of the oxygen atom. These orbits are called energy levels or energy shells, and they are the paths electrons follow around a nucleus. The hydrogen atoms aren't stationary. They keep moving around the oxygen atom, maintaining an angle of 105.4 degrees between them. By comparing the number of electrons orbiting the oxygen's nucleus with those orbiting the hydrogen nucleus, we can see that oxygen is more electronegative than hydrogen. This makes H2O a polar molecule. The positive end, formed by the two hydrogen atoms with fewer electrons, is attracted to another water molecule's negative end, the oxygen. This attraction creates hydrogen bonds. Now that we understand the water molecule's polarity, oxygen being more electronegative than hydrogen, and negative charges attracting positive charges, we can better comprehend how hydrogen bonds are formed and how water molecules stay close. Let's observe how hydrogen bonds are formed in slow motion. While these bonds are relatively weak compared to other chemical bonds and last for only a fraction of a second, they are strong enough to keep water molecules close together. This is why H2O molecules stay close but don't stick together. New hydrogen bonds form constantly, allowing water to flow smoothly. Moreover, this attraction created by the hydrogen bonds helps holding water together and explains the creation of a slight dome when you fill a glass to the top.